ஸ்டார்ட் பண்ணிட்டோமா? We'll start. I'm ready. Ma'am, ready? I'm start பண்ணிட்டோமா? Good morning to all. Myself, Dr. P. Jayaprakash, Assistant Professor of Physics, Department of Science, St. Joseph Institute of Technology. I extended warm welcome to all the participants for various colleges and universities. With the blessing of the Almighty and with the support rendered by our management, St. Joseph's Group of Institution, Chennai, and with the Department of Science, St. Joseph's Institute of Technology, proudly present you an international webinar on electric vehicles, the future of transportation by Dr. D. Arun Kumar, Institute of Multidisciplinary Research for Advanced Materials, Tokyo University, Japan. We are very much happy that he is readily accept our invitation with his busy schedule, and we are grateful to his passion for his presentation. We thank to Dr. D. Arun Kumar for being with us for his presentation. It is my pleasure to introduce the resource person, Dr. D. Arun Kumar, for his presentation on electric vehicles, the future of transportation. He is presently working as assistant professor in Tokyo University, Japan. His research area of interest is solid-state battery, energy device, and ion dynamics. I am briefing the profile of the Dr. D. Arun Kumar on behalf of my department and college. Dr. D. Arun Kumar is studied BSc Physics in Arinjaranna Government Arts College, Cheyyar, Tamil Nadu, India, and obtained his master degree in physics from Bharathiar University, Coimbatore, Tamil Nadu, India, and he received PhD degree from Bharathiar University, Tamil Nadu, India. After the successful completion of PhD degree, he joined lecturer in Arinjaranna Government Arts College, Cheyyar, Tamil Nadu, India. Later on, he went to Korea Institute of Energy Device for doing active research in the field of solid-state ionics. He successfully completed his postdoctoral work in Institute of Multidisciplinary Research for Advanced Materials, Tokyo University, Japan. He has joined as assistant professor in Tokyo University and doing active research in the field of solid-state ionics. He has published more than 30 publications in various reputed journals with a good impact factor and successfully completed 3 research projects. With the short introduction, I take immense pleasure invite Dr. D. Arun Kumar to deliver the webinar. Welcome, sir. One more request to the participants: if you have any questions during the presentation, please type them into the chat box. Kindly mute your audio and video. We are looking for your active participation to make this webinar for a grand success. Once again, thank you. Thank you all.
Sir, you can start, sir.
Okay. Good morning to everyone. First of all, I would like to thank Dr. Jayaprakash for giving this opportunity to share our research details with you all. And as he has given a short introduction about me, I graduated from Arinjarana Government Arts College in Cheyyar, and I did my master's and PhD in Bharatiyar University. And after completing my master course in Bharatiyar University, I joined as a lecturer in Arinjarana Government Arts College. During that time, I think Dr. Jayaprakash, he was doing his third year of bachelor's. At that time, when I informed everyone that I would be going for PhD, because in our college, not many people during the year 2004, there was not many 2002 sorry, it was in 2004. There was not many people who are willing, who know about where to do PhD or any other things. During the time, there was a group of people, including Dr. Jayaprakash. They were very much interested to know about the details, where to do PhD, how to approach teachers, or how to approach professors, and all these things. And after I worked there for 1 year as a guest lecturer. And after that, I joined for my PhD in Bharatiyar University. I completed it in 2011. And then I moved to South Korea to work as a postdoctoral fellow. And then from 2013, I moved to Japan, Tohoku University. And from 2013 to 2017, I was working as a postdoctoral fellow. And from 2017, April, till now, I'm working as an assistant professor. Because after 2011, after my first postdoc in Korea, when I returned to India in 2013, I met Dr. Jayaprakash. He was also working in the same college after getting his master course, and during that time he said he's planning to join for PhD. I was really surprised, and I was really happy that there are still some students who are taking the steps, who are following us, who are following the words, and to do active research and to grow up. And I feel so happy that he has joined in a very good research institution, and St. Joseph's College, which is very well known in Chennai. And I would like to thank Dr. Manimekalai for inviting me this lecture, to present this lecture. So now I'd like to share my details. Excuse me.
What happens?
Some trouble. I cannot share. Initially, I was able to, but now it shows some error. Sorry for the trouble. Yep. Now can you all see the presentation? Dr. Jayaprakash, is my presentation visible?
Yes, sir. Your presentation is visible, sir. You can start.
Yeah, thank you so much. So the title of my presentation is Electric Vehicles, the Future of Transportation. Actually, this work is a collective work from our research group, and I have just mentioned only the important members, and there are many other students and research fellows who have worked or contributed for this all the work to be presented in this webinar. So actually, this is Professor Junichi Kawamura. He is our group leader, and he is the one who has initiated, who has motivated us to work towards all solid state battery. And this is Professor Kuwata. He is a specialist in all-solid-state thin film batteries. Maybe I will present a slight results from his work. And this is Dr. Nitya Heller. She is a postdoctoral fellow, and she has contributed a lot for the characterization of the materials, for the cathode materials and the degradation problem in all these things, which I will discuss soon. So this is my present affiliation, Thok University. You can see it has a good scenic view. This is located in Sendai, and this university has been ranked number 1 in the Times Higher Education in Japan for the year 2019. And to all the people in India, we are all very much aware of about Kyoto University or Tokyo University, because these are the institutions which are in news every 5 years once, because many Nobel laureates come from these institutes. But Tokyo University, there are still there are 2 or 3 people who have missed the Nobel Prize because of the delay in the publication or something. There are something background running behind, but Tokyo University ranks among the top 3 in Japan. And this Tokyo University, it offers good higher education, and it is very strong in material science. So people who want to do research or want to do collaborative research, you can easily approach. You can find a professor and you can contact with them. There are many research teams from India collaborating with Tokyo University in material science. And to show exactly where this university is located, this is located in the city of Sendai, which is about 500 kilometers far from Tokyo. And to mention exactly, this is the city where the 2011 Great Eastern Japan earthquake took place. I'm sorry, excuse me. Okay, now I will enter into my presentation. It's about global warming. So as we all know, everybody around the world, we are now speaking about global warming, saying that each and every year the monsoon it is getting delayed by 1 or 2 months, or else the monsoon is coming ahead. As we all know, we don't face so much of typhoon or monsoon season in India nowadays. And similarly, we can see the effect of the global warming in the summer, because year by year the temperature in India is getting increasing. Initially, we used to have about temperatures in around 35 to 36 degrees centigrade in Chennai, but nowadays it's reaching up to 39 or 40 degrees centigrade, and maybe it will increase in the future. So if it is going to continue as the same, if the trend of the increase in temperature of the global temperature, if it is going to increase in the same rate as of now, then the average temperature of the Earth, it will increase about 4 to 5 degrees by 2100. So if it happens, as we all know, as we have read so many reports, the Arctic ice will melt, and the sea level will increase, and there will be drastic changes in the atmosphere in the monsoon season and everything. So to control all these things, what we have to do is to decrease the temperature, at least, because it has been reported to decrease the temperature within control of about 1.5 degree to 2 degrees. This is with respect to the temperatures before the industrialization period. During the 19th century, end of 19th century, the global temperature was about, at present the temperature it is about 2 degree increased. So if we can decrease the 2% 2 degree increase, then the global effect of global warming might be reduced. So to achieve this, what we have to do, there is we have to take several impacts, several changes. What we have to do is to reduce the carbon dioxide emission, and then we have to move from the burning the fossil fuels to the renewable energy sources. And if we do this, the global warming, the temperature of the Earth can be decreased by 2%, and by 2100, the average temperature of the Earth will be around 1% to 2%. That is less than 3% decrease. That is 3% decrease, which will be enough, which will be supportive for the sustainability of the planet and for the mankind. And as we all know, the air pollution in India is very, very high. So this is just this animation was made in 2016. How the air pollution in Delhi is affecting India, because we all know Delhi being the capital of India, there are a lot of industries in and around Delhi, and the number of automobiles it is running in Delhi, and the carbon dioxide emission from it's really very, very high, and the average acceptable PM10 level and PM2.5 level, it is about 5 times the average value of which should be, but nowadays it is getting increasing. So how can we reduce this? To reduce this, initially the Delhi government, they moved from diesel and petrol vehicles, and they introduced the natural gas fuel, and then still they could not control the air pollution in Delhi. And what is the case in Chennai? Last year it was a big news. As we all know, this data was taken in November 6, 2019. The state of air quality in Chennai, it is reported to be unhealthy. So as Chennai being becoming an industrial hub, maybe it will become a global hub in the next 5 to 10 years, because of the increase in the industrial industries. So even in the present case, if it is going to increase, then the rate of air quality index, it will become worse and worse. So to control this, we should control the emission level. That is, we can control the usage of automobiles, and then the industry, and we are using coal plants. That is, we burn coal to make electricity. So if we can change from the coal-based plants to renewable energy sources, such as from hydroelectric power or wind power, or through solar cells. So if we move from this, it will be better. And this graph shows the global greenhouse gas emissions by economic sector. For the electricity production, 25%. It contributes to 25% of the carbon dioxide emission. And agriculture, forestry, and other land use, it contributes 24%. And transportation is about 14%. And industrial use, it is for 21%. And the one which we can move at the earliest is moving from the combustion engines, from transportation. The 14% contribution from the transports can be decreased as early as possible. So everybody, the countries around the world, they are all having a target that to change from the internal combustion engines to the electric vehicles, or to the next generation vehicles. So in Europe, they have decided by 2018, maybe it is previous data, they have a target of about using zero emission vehicles by 2018. In China, it targets about 2 million electric vehicles by 2020 in the present state. And India, we have a target of about at least contributing 30%, using 30% of electric vehicles by 2030. But our government has a vision that by 2030, all the vehicles in India must be electric vehicles or hybrid vehicles. So we hope we could achieve the target as early as possible. And to address this, in 2015, the global climate COP21, which is to say the Paris agreements, during that meeting, 195 countries agreed to do or contribute to the decrease in the global warming. So they have decided, the conclusions were to keep the global warming by 2 degrees Celsius, and then the rich countries must give money to, and they should give the technology to the developing, and the developed nations should contribute to the developing nations. And we have to review the progress in 5 or 6 from by 2023. At present, because of the corona pandemic, this review mechanism has been postponed to 2025. So by 2025 they will review the strategies taken by all the countries, and then they will modify the plans accordingly. And we are all expecting by 2030 there will be a larger decrease in the carbon dioxide emission. And this is I'm sorry, this is in Japanese, but I will explain this in easily to understand. These are all the strategies or the targets fixed by the governments to decrease the carbon dioxide emission. China, they have decided by 2030 to reduce the carbon dioxide emission by 60%. That is, so 60%. And the European Union, they have decided by 2030 to 40%, and India has the same, to 30 to 35%. So if we can decrease these values by 2030, then the global warming issue will be rectified. So how we can change from this? So we are saying that by carbon dioxide emission. So how can we move from this to the? So next, the researchers are all we are all looking forward, or where we are moving is to move towards low carbon society. Now we are all mostly dependent on the carbon based society. We are using more and more fossil fuels. So we should reduce the usage of fossil fuels, and we move from fossil fuels to renewable energy sources. So now how we can move, instead of we can use energy efficient appliances. So as we all know, previously we were using fluorescent lamps, which consume more and more energy, and the lifetime of those was very less. But nowadays everybody recommends everybody plans or uses LED lights, which have a lifetime of about 10,000 hours. So we are all moving to energy efficiency. So the power consumed by the appliances is getting low and low, so that the electricity required to use this equipment for 1 year, maybe it can be used for 5 years. And then we are all now banning plastics. So we are moving from plastic based society to paper based, or to environmentally friendly products. And then we can move from the fossil fuel generation for the coal burning, and to renewable energy sources such as solar cells and hydroelectric powers and thermal energy stations. And then from the next one is the moving from the internal combustion engine, that is from using diesel and petrol to battery vehicles, to electric vehicles. So this is how the future society is moving. We are all on the way of this, that we have achieved developing high energy efficient appliances, and we are banning plastics, and nowadays we are using more and more environmentally friendly products and renewable energy. And the one which we have to focus more and more is to use renewable energy, and develop new electric vehicles which can be used for the society. And this is the to move to the society. Government of India from 2010, they started to give incentives, or they started to give contributions to develop the electric vehicles sector. So in 2015, the government, they said they will contribute about 10,000 rupees to 1 lakh rupees if you are going to buy an electric vehicle. And nowadays we are having, the government has a national mobility mission projects. So now India is more looking towards the electric vehicles, to develop electric vehicles in India, so that the cost of the electric vehicle may be to get less. And now the government is organizing or conducting meetings and discussions to to change the infrastructure, because nowadays if you are going to develop electric vehicles, you need charging stations. So in each and every metro city, or you have to have a charging station which would be supportive to the usage of electric vehicles. And this is a comparison between the internal combustion engines and the electric vehicles which are sales in India. In 2018, in the year 2018, the internal combustion engine proportion is about the sales of internal combustion engine is 40 lakhs units has been sold. Of this, around 80% contributes to the motorcycles, bikes, motorcycles, and 14% contributes to the cars. And in the field of electric vehicles, as you can see, till now, around 94% vehicles which have been electrified vehicles is only auto rickshaws and mini trucks. But the contribution of motorcycles, bikes, and cars, it's really less. It's only about 5 to 6%. So what we have to do to change from the internal combustion engine to the electrified society, we have to increase the sales increase the number of cars and automobiles. As we all know, nowadays more and more electric two-wheelers, electric scooters is being launched in India. And so in future, the main reason which everybody is worried to buy an electric vehicle is about the charging distance, about you at one charge how long the vehicle can go. It's about, if it is only 60 kilometers, a person who is commuting to work from Chengalpattu to Chennai, if in a busy traffic, he cannot return back to his home. So we want to have a battery which lasts very long, maybe about 100 kilometers or 200 kilometers, so that it can be used. And after this, in 2019, the electric vehicle sales in India, about 630,000 units of auto rickshaws has been sold, and 126,000 of scooters has been sold, and the number of cars is slowly increasing up to 3,600. And this is the contribution of the electric vehicles purchased by each and every state. As Tamil Nadu contributes to about 10% of the electric vehicles sales. On Maharashtra and Delhi, they buy more and more electric vehicles to decrease the pollution. So if we want to move from the internal combustion engines to decrease the amount of carbon dioxide emission, what are the next vehicles which we can move? So as we all know, there are the future next generation vehicles are about 4 types. One is the hybrid vehicle, which is HV, and the plugged-in hybrid vehicle, PHV, and the electric vehicle. And the next one is the fuel cell vehicles. So what is the difference between the hybrid vehicle, plugged-in hybrid vehicles, and then the electric vehicles? So in the case of a hybrid vehicle, these cars, for example, if it is a Toyota Prius, this car uses the petrol or diesel as the main fuel, but a battery is installed in it. So the battery cannot be charged. So during to start the car, you will use the petrol to start your vehicle, and then during the running of the car, if your car is moving at a speed of 40 kilometers per hour, then the energy will be taken from the battery. And if you want to increase the speed of your car, then the power supply from the battery will be disconnected and petrol will be used as the fuel. But in this case, in the case of hybrid vehicles, the petrol engine which will be functioning all the time, so usage of petrol is not completely reduced in this case. The battery placed in the car, this battery cannot be charged separately. So these cars use a technique called as regenerative braking mechanism. So when you apply brakes, then the battery placed in this car, it charges automatically, and the energy can be used. So you cannot separately charge this car. In the case of plugged-in hybrid vehicles, this follows the same principle as the hybrid vehicle, but you can charge the battery separately. So this uses both diesel or petrol and electric. So you can charge both. So you can decide which one to use at present. At first, if you want to use only petrol, then you can. If you want to use only electric, then it is also possible. So it is based on the user's choice. And the electric vehicle, as it mentions, it is only 100% electric. So only batteries are installed in this. So this type of vehicles is Nissan Leaf. So these Nissan Leaf and Tesla model batteries. And the next one is the fuel cell vehicles. This is Toyota Mirai. So this uses an hydrogen fuel as a tank, and it absorbs oxygen from the atmosphere, and the chemical reaction between hydrogen and oxygen takes place, and the emission is only water. So hydrogen reacts with the water, oxygen to form water, so which is as the emission. But the problem with the fuel cell vehicles is the hydrogen storage. The fuel is hydrogen. So to have a hydrogen storage container, to compress hydrogen and to store in the battery in the car, it's really highly expensive. The technology used to compress hydrogen or use the vehicle is expensive, and the hydrogen gas stations, which has to be installed in everywhere around the country. So the installing of the gas stations and the infrastructure development, it takes more time. So in the near future, how the industry will move is from using to hybrid vehicles, and then or plugged-in hybrid vehicles. And nowadays the usage of electric vehicles is increasing more and more. As we all know, in India nowadays, Mahindra Electrics and Hyundai, they are launching electric vehicles by 2008, from 2018 to 2000. So if the shift from internal combustion engine to electric vehicles is going to change, then we can reduce the carbon dioxide emission. So all these electric vehicles, they use batteries. So why people are hesitating to shift from the industrial combustion engines to the batteries? So first of all, I would like to start from the real basics. What is a battery? And how can we increase the efficiency of the battery? And what are the ways we can increase the efficiency of the battery? How it can be used in the electric vehicles? So what is a battery? So a battery is a device that converts stored chemical energy into electrical energy. So in this case, the chemical energy is stored into electrical energy. So if we have considered a sodium chloride solution, and we have copper and zinc electrodes, so inserting this, the sodium ions, sodium and chlorine ions is present in this case. So if you connect the cathode and anode, or the electrodes copper and anode, to an external circuit, you get electricity. So the chemical energy present in the cell is transferred into electrical energy. A simple battery which can be demonstrated is a lemon battery. So if you insert zinc and copper electrodes into an lemon, and if you connect it to an external circuit, you will get a potential of about 0.97 volt. In this case, the hydrogen ions, as we all know, citric acid present. Citric acid CH3COOH. So H plus and CH3COO minus, it separates, and the hydrogen ions, so the electrons flows to the external circuit, and we get a potential. The potential given by this lemon battery is 0.97 volt, and it is irrespective of the conducting medium. The potential is depend mainly on the potential difference between the electrode materials, that is the potential difference between zinc and copper is the potential of the battery. So there are a lot of batteries which has been developed starting from the 18th centuries. So batteries are mainly of two types. One is the physical batteries, that is the solar cells. So here the electrons from the semiconductor materials is used as the conducting medium, and the other one is the electrochemical matrix, where the chemical energy is converted into the electrical energy. So in the electrochemical batteries, it is separated into three types. One is the primary batteries, that is as we all know, it is a use and throw battery, so you can use the battery only one time, and then the second class is the secondary batteries, which is a rechargeable battery. So you charge and discharge the battery a number of times, and after the degradation of the battery, you are going to replace it with. And then the third one is the fuel cells. As I explained before, it uses hydrogen and oxygen as the fuel. So there are several battery technologies which has been developed based on for the primary batteries: zinc as the anode and carbon as zinc as the cathode, anode and carbon as the cathode batteries, and zinc manganese oxide batteries. So most of the batteries which we use, the AAA or AA cells, primary cells, are based on these everyday batteries, and Duracell or Nippon batteries are based on the zinc manganese oxide cells. are zinc carbon based cells. And then the button cells, which we use in watches, and what we use in the remote control toys, they use lithium battery, CR2032 as the CMOS battery. And then in case of watches, they use silver battery. And zinc air battery is used in only in some places where it is used in the hearing aids. So people who are using hearing aids, they need a battery backup power supply. So zinc air battery is used in this case. And there are the secondary batteries, which are of 4 types. One is the nickel cadmium batteries, and the other one is the nickel metal halide batteries, the lithium ion battery, and the lead acid battery. As we all know, lead acid battery has found a very strong position, or it contributes to, it is present in each and in most of the automobile vehicles, and it is used as a backup power supply in our home to generate to store electricity. So next, the electric vehicles has been developed by using all these 4 technologies: lead acid, nickel cadmium, nickel metal halide, and lithium ion. So the development of electric vehicles is just not, it doesn't start from only in the 20th century. Ever since the battery was invented, there have been several attempts made by researchers to to develop a electric vehicle. So now I will show the history of the electric vehicles. And the next one is the important milestones, when the battery was developed. So the first, the invention of a electric storage device, that's a battery, was invented in 1791 by Galvani. He used 2 different electrodes. One is zinc and copper. He was doing a biological experiment. He was dissecting a frog, and he used 2 electrodes to pin the frog's legs, and he connected it to an external circuit. So when a common nerve, which was present in the frog's legs, was was touched by mistake, the legs moved. So Galvani thought that there is a conduction in the change, and there is a movement of electricity. So it was the first idea of battery. And in 1800, 9 years later, Alessandro Volta, he found he developed the first battery. He used copper and zinc electrodes, and he used the electrolyte solution, and when connecting together, he achieved a potential of about 1.2 volts, 0.92 volts. And then in 1859, Planté from France, he invented the lead acid battery. And from 1859 to 1899 till this time, many people try to modify the lead acid battery and to increase and to develop it. And in 1899, Jugner from Sweden, I think so, he developed the nickel cadmium battery. This is the first alkaline battery which has been developed. And the first battery to be commercialized is lead acid battery. It was invented in 1859 and it was commercialized in 1904. And then the nickel cadmium battery, which was invented in 1899, it was commercialized in 1964. So in after 1964, most of the mobile devices or most of the personal computers, they tried to use nickel cadmium battery and the first mobile phone to be developed by Motorola used the nickel cadmium battery. And then the next one is the development of commercialization of nickel metal halide battery. It was in 1989, and then in 1991, as we all know, Sony launched the lithium ion battery based on the lithium technology. And so how long it takes to develop a battery for the lithium ion, how long it took for the lithium ion battery to develop. So it was in 1975 the first idea of using a lithium ion battery can be developed. So in 1975, it was Professor Stanley Whittingham. He used lithium metal as the anode, and he used a layered material, titanium disulfide, as the cathode, and he tried to develop a secondary lithium-ion battery. And the battery, it gave a potential of about 2 volt. Unfortunately, it could not be recharged for a longer time because of the formation of the lithium dendrites, which degraded the battery. And it was in 1980, lithium cobalt oxide was discovered by Professor John Goodenough. And it took from 1980 to 1991, to develop the first commercializable lithium-ion battery. It was done by Sony company. And lithium manganese oxide, and most of the materials which have been new materials which have been developed in case of lithium-ion batteries is the development of the cathodes, because in this case only we are changing the cathode materials and the anode material is fixed. So I will explain how how changing the cathode materials will change the potential of the battery or will increase the performance of the battery in the next slides. And since 2006, there have been no new materials has been identified to use, and most of the materials which have been reported uses either lithium manganese oxide or lithium iron phosphate, and they are changing the ratio in these compounds to increase the performance. However, still the next breakthrough is still we are all waiting, and we are all trying to find the next breakthrough. So from this, the lab to market is very slow. So it takes more time to develop a battery, and the scale up and manufacturing is a challenge. So as we all know, there are several types of batteries which are being developed, and in one vehicle, if considering a car, there are several types of batteries used in it. So the first one is the lead acid battery. We know that this is a starter battery. So to start your car, we use the lead acid battery, and in your keys, they use lithium battery, and the main battery is based on nickel metal halide batteries and lithium ion batteries. So there are several types of batteries which are being used in the cars in the future, in the next generation cars. And the electric vehicles, as I said, it started when the first battery was commercialized. So it was in 1904 the lead acid battery was commercialized, and in the same year the first battery has been first electric vehicle has been developed by Siemens company in Germany. It was in 1904. And as we all know, the technology, the chemistry behind the lead acid battery is it uses lead oxide as the cathode and lead as the anode, and sulfuric acid as the electrolyte. So during charging and discharging, these reactions takes irreversibly, and it gives energy to us. And these batteries, they can be designed depending upon your requirements. So if you make the electrodes thinner, and if you insert a number of electrodes into a cycle, you can extract more energy. And if you use thicker plates, you can use it in your home backup as the UPS backup battery. And so it was the first vehicle was in 1904 which used the lead acid battery, and the research continued more after that also, and not many cars, electric vehicles could be developed in the meantime, and because of the demand. And as we all know, after the launch of internal combustion engine in 1907 by Henry Ford, and the energy delivered by the car, and the price of the car was very cheap compared to all these electric vehicles. The usage of the development of these electric vehicles is not very rapid, and it was very, very slow. And there were some companies who have been trying to develop the electric vehicles starting from day one. So the next battery to be developed is, as I said, is based on the nickel cadmium battery technology. So in this case, nickel hydroxide used as the cathode, and cadmium as the anode, and electrolyte H2O, water is used as the electrolyte. And if you say it's H2O, it is based on alkaline solution, alkaline KOH, aqueous KOH is used as the electrolyte. And during the charging and discharging, this chemical reaction takes place irreversibly, and then we could get a potential of about 1.2 volt. So this potential of 1.2 volt is the potential difference between the cathode cadmium and nickel hydroxide. And the advantages of these batteries, it can be quickly charged and discharged, and it is quite inexpensive. And there are one big problem considering the nickel cadmium batteries. It is we called as the memory effect. That is, if you discharge the battery only up to 40%, and then if you are in a hurry, you charge your battery, then the battery charges to 100%. But when you again discharge the battery to 40%, it will not when you discharge the battery, it will not discharge to the actual 0%. It will discharge it up to only 40%. That is, it will keep the memory of the previous value, and then you cannot extract 100% of the efficiency. So this was the biggest problem considering the nickel cadmium batteries. So to avoid this, every time you use this battery, you have to discharge the battery completely, and you have to charge the battery completely. So this was the problems with the nickel cadmium battery. And it was in 1910 or 1908, or Thomas Alva Edison in 1904 or 1905, he said that he will make a car which can run 1000 miles. So it can go around America without with this electric car. However, this car, he used the nickel and cadmium as the nickel and iron instead of cadmium. He used iron. There were several issues concerning the safety of the battery, that is the electrolyte leakage and the design of the battery. So the commercialization of the battery, this project started in 1903, and it took about 10 years, and he was able to successfully launch the car only in 1910. And by the time Henry Ford, he launched the internal combustion engine cars, and the Edison's car, which he said which can last for 1000 miles. The price of this car was about 10 times higher than the internal combustion engine. Therefore, Edison has to give up on this project, and the commercialization of this vehicle, it was stopped at this stage. And then people still try to use the same battery to develop electric vehicles even after 1950s. These Enfield 8000 and Henny Kilowatt and Rambler American, these cars are also based on nickel cadmium batteries, and these cars were developed in 1960s. But however, due to the decrease in the demand, or there were not many people who were willing to buy these cars because of the price, and everybody was satisfied with the internal combustion engine which used, and the performance of that. And then comes the third generation of the vehicles, which I could say it is based on the nickel metal-laden batteries. As I said, nickel metal-laden batteries was launched in 1989, and from this battery is cheap, and this battery could have a good capacity compared to the nickel cadmium and lead acid batteries, and this is environmentally friendly, and this has high specific power, and this battery could work at low temperatures. So considering these advantages, this battery was first used to develop an electric vehicle in 1997. Toyota Prius, they used this is a hybrid vehicle which used the nickel metal-laden as the battery backup, and the petrol as the main fuel. So starting from 1997, Toyota has been launching different versions of the nickel metal-laden batteries. And by the same time, in 1998, General Motors in US, they also launched the hybrid electric vehicle to General Motors EV1. And in 2000, Honda also entered into the hybrid electric vehicles market. So next comes the fourth generation, I can say. After the launch of lithium-ion batteries in 1991 by using lithium cobalt oxide and carbon graphite as the cathode and anode materials, this battery was seen as the game changer. So because the amount of current or the capacity of these batteries are three times higher than the previous generation batteries, that is of the nickel and metal-laden batteries. It was only about 1.2 volt, and the maximum potential was about only 2 volt, which is given by the lead acid batteries. But in case of lithium-ion battery, the potential is about 4 volt, and the capacity of the battery is about 9900 milliampere hour. So you can have a battery with high capacity and high potential, so that this battery could be supportive, could last longer, and it will be good for the electric vehicles. So in 1995, Nissan they launched the first electric vehicle by using lithium-ion batteries. To develop these vehicles, Nissan has used the similar type of cylindrical cells, about 4,000 combined joined together in series to achieve the electric vehicle. And by the same time, in 2000, from 1995, Nissan was developing lithium-ion battery, and it was in 19 I'm sorry, it was in 2008 until Tesla entered into the market. Tesla started to use the lithium-ion batteries. So in this Tesla Roadster, about around 6,900 individual lithium-ion cylindrical cells has been placed to run this electric vehicle Tesla Roadster. So Nissan was the first company to develop a separate battery to be installed in the electric vehicle. And starting after that, after Nissan gave this idea or launched these vehicles from 2009, there have been several companies which have been developing electric vehicles. And it was in 2009 in BYD. It is a China-based company. They used a different electrode material, but the capacity of the battery is very less. But still, they used this to develop electric vehicles. And the next generation vehicles, or the cars which are going to be launched from now on, is 2020. Tesla, they are developing new lithium-ion batteries based on different cathode materials, and which can the limitation of this car, Tesla says that this car can run up to 500 or 600 kilometers in a single charge. So what we all looking forward is to, in the first Nissan Leaf model launched in 2009, the distance that can be traveled by in a one charge is about only 200 kilometers. So after 200 kilometers of running, you have to charge your car again. So now the distance that can be traveled by one charge has been increased about 3 times. So everybody now, we want to have a car that can run for about 1,000 kilometers at a single charge. So Tesla is working for this. And to develop a battery, most of the car companies still buy the battery from a separate company and they install on it. And Tesla, they want to develop a battery by their own. So they have constructed, or they have developed a factory called the Tesla Gigafactory in Nevada, USA. This factory is, the size of the factory is nearly same to the total number of the factories which are developing lithium-ion batteries around the world. So the batteries which can be developed from as a total in the world is equivalent to the Tesla will develop the same number of batteries in one place. So the battery transportation and other costs involved in developing these batteries will be reduced. And Tesla, they said they can offer a cheap car if by using this. So what we need for the electric vehicles, so if you are going to buy a car, and what are the parameters which you have to you look for? The first one is you look for the price. The price of the car should be cheap, and how long the car can run on by using one single battery pack. And if you are going to dispose the battery pack, and how toxicity if you are an environmentally conscious person, and how fast you are going to charge your car. So you travel for 500 kilometers, and if you want to charge your car, so how long you will wait? In the present case, people used to charge the car for 12 hours, and for some people, for some people who are busy in their work, they need to charge the car in only about 30 minutes. So that short time of charging should be possible. So, and then specific energy and specific power. What do I mean by specific energy and specific power? And then the third one is the safety. How safe the car will be if you are going to use an electric vehicle. As we all know, starting in the 2000s, I think so, there was a car electric vehicle bought by the well-known actor in Tamil Nadu, R. Parthiban, and the car got into flames in Mount Road. So he was driving the car, and the car got exploded, and the battery got exploded, and the car got in fire. So we need safer vehicles. So what do, and then the next two is the specific power and specific energy. What do I mean by specific energy and specific power? The specific energy, sorry, just a moment. So specific energy. So your battery, when you're going to buy your battery, the specification is given as 2100 milliampere hour. So the 2100, the 2 ampere current from your battery, how long you are going to extract the energy. So that means that you have a high, if you are going to remove the energy very slowly, it is about high energy density. And if you are going to remove the energy within a short period of time, that is, you are going to take the 2 ampere current in only 30 minutes. And in the case of high energy, if you are going to take it in 4 hours, so decreasing the amount to remove the power from the battery, we call it as high power. So in the case of to explain simply, so if you are going to have an electric vehicle, and you are going to drive the car at about only 40 kilometers per hour. So if you are going to have a battery of about 4 amperes per hour, then if you travel at a speed of 40 kilometers, then your car can last up to 40 kilometers. For about 40 kilometers you can drive 40 kilometers. However, if you are going to use the same battery in a Formula 1 vehicle, so these cars, the Formula 1 vehicles, it needs more power. So to start to run the car at such high speeds, you need high power. So you have to extract the current from the battery at a very faster speed. So this is the difference between high energy and high power density. So what we need is, if you are going to use your car on a day-to-day basis, if you are going to commute by using this car, you need a high energy density battery. However, if you are going to travel in a highway, if you are going to go for long distances, you need high power from your you have to extract high power from your battery. So if you are going to travel at a speed of 80 kilometers per hour. And this simple difference is to run a marathon race, you need more stamina. That is, you need more energy. You have to store your energy, and you have to spend it very, very slowly. And to run a 100 meters race, you need more power. So within a short period of time, you can give you all your energy, and after 100 meters you will be completely exhausted. So a battery should have both the performance. To find the balance between these two is a trivial technique to develop an electric vehicles. And what are the batteries? How the present situation is now? So the energy density, as I said, how long you can use the battery, and the power density, how fast you can remove the energy from the battery. So there are, from the developed battery technologies, lead acid battery is lower, and lithium ion batteries is here. Lithium ion battery gives the high energy density, and comparably it shows high power density also, so that you can use the battery to run at a longer time and at a longer speed, at a shorter time also. And so combining this, to increase the performance of the battery, to have an electric vehicle, we need a high energy density. So now the lithium ion battery has an energy density of about 200 watt hour per kilogram. So we want to increase this up to 500 or 600 watt hour per kilogram, and we want to increase the power density from 1000 to 2000 or 3000. So we want to have a battery in this region. So what are the ways to improve the battery? So we can, as I said, initially the batteries developed by nickel metal hydride was only about 1.2 volt, and when we have a battery, lithium ion battery, the voltage value is 4.2 volt, so it has high capacity. So, and we can change the materials, combination of the cathode and anode materials. So how we can change this? And next is the next generation batteries. What are the batteries which post lithium ion batteries? It is We can use sodium ion battery or lithium metal battery, lithium air battery or redox flow batteries, or we can change the lithium ion from using the lithium ion to all solid state or other batteries. So I will give a small detail in this on these topics. So the structure, how the lithium battery is going to work, is working. So as we all know, we say the lithium ion battery, it means the lithium ion is in motion. So the cathode is made up of lithium cobalt oxide or lithium cobalt oxide, lithium manganese oxide, or any other transition metal containing elements. And the anode is a carbon. That is, at present we are using carbon as the anode. However, even if we say that this has lithium ion battery, the anode materials is not carbon. So during charging and discharging, carbon being a layered structure, the lithium ions intercalate and deintercalate during each and every charging and discharging cycle. So the electrolyte, the organic electrolyte, an electrolyte is used to transport the lithium ions from the cathode to the anode. So this figure shows the charging and discharging mechanism. This, so, the voltage of a lithium ion battery is, we have a cathode and an anode and an electrolyte to transport the ions between the cathode and the anode. So during the voltage of the battery is given as V open circuit is the difference between the potential of the cathode and the potential of the anode. So therefore, if you are going to have a common potential, common anode, if in the present generation lithium ion batteries, we use carbon as the anode. So the carbon has a potential of approximately 0.3 electron volt with respect to standard hydrogen electrode. Our lithium cobalt oxide has a potential of about 4.2 volt. So the potential of difference between cobalt and cathode and anode is 4.2 minus 0.3. It will be about 4.2 volts, 4 volt or 4.2 volts. So the open circuit voltage depends upon the choice of the cathode and the anode materials. So at present there are three classes of materials, cathode materials: layered, spinel, and olivine type materials, which can be used to increase the performance of the battery. And the anode, at present we are using carbon. In future, maybe we can move from we can change the carbon to lithium metal. If you are going to use lithium metal as the anode, then the performance of the battery and the potential of the battery will be increased to a larger extent. So as I said, the potential difference of the voltage of the battery depends on the potentials, potential difference between the cathode and the anode. So here, this is the band structure of the combined battery developed. So in this case, lithium, the energy level of lithium metal is at the top, and the energy level of cobalt, lithium cobalt oxide, is at the bottom. So as you can see, the energy difference between the Fermi energy level of lithium cobalt oxide and lithium metal, lithium is about 4 electron volt. So therefore, if you are going to use lithium and lithium cobalt oxide, you can get a potential of 4 electron volt. So next, if I am going to change my cathode from lithium cobalt oxide to lithium manganese oxide, so you can see the energy difference between the lithium Fermi energy level of lithium and lithium manganese oxide is 4.1 electron volt. And if I am moving from going to change from the cathode from lithium manganese oxide to lithium nickel phosphate, then I can get a potential of about 5.1 electron volt. Therefore, if you have a wider potential difference, then your battery can have could deliver high specific capacity and high energy. So based on this, there are three classes of cathodes. One is based on lithium iron phosphate. This the potential difference between lithium iron phosphate and lithium is about 3.6 volt, and the 4 volt cathodes, lithium cobalt oxide, and the 5 volt cathodes, lithium nickel phosphate and lithium cobalt manganese oxide. So these are the typical cathode materials which I said: lithium cobalt oxide, lithium manganese oxide, and lithium iron phosphate. And this table shows the specific capacity. Here, the actual specific capacity of lithium cobalt oxide, theoretical specific capacity calculated from the energy band structure, is about 272 milliampere hour. However, the achieved value from the lithium cobalt oxide is only 140. So that is only 50% of the specific capacity has been achieved from lithium cobalt oxide. And similarly, in case of lithium manganese oxide, the specific capacity, theoretical specific capacity is 148, and only 65% up to about 120 milliampere hour has been achieved, extracted. And in the case of lithium iron phosphate, about 95%, 160 milliampere hour per gram has been extracted. So what restricts the capacity? Why we cannot use the extract the complete efficiency from lithium cobalt oxide and lithium manganese oxide? So I will explain this. So during charging and discharging, as I said, the lithium is being intercalated and deintercalated. That is, lithium is being extracted and inserted into lithium cobalt oxide. So during discharge, lithium ion is going to during discharge, lithium cobalt these lithium ions is going to get inserted into lithium cobalt oxide. That is, initially when Li is 0, that is cobalt oxide COO2. It is not in cobalt oxide is in COO3 structure. So adding one of lithium into it, inserting lithium into it, changes from cobalt CO3O4 structure to layered structure CO to LiX COO2. So you can see there is a step like behavior. So why there is a step like behavior in this? Because during charging and discharging, when there is, so the top figure A shows the structural change, structure of lithium cobalt oxide during charging and discharging. So how it changes when lithium is added into it. So, and this is the amount of lithium, and in figure B, the x-axis is amount of lithium, and the red line shows the charging and discharging curve. So the symbols O1, O3 mentions identifies the structure. That is, O3 is orthorhombic structure 3. So O3 is here, orthorhombic structure, when lithium LiCOO2, lithium cobalt oxide, is in orthorhombic structure 3. So when you are going to remove a small amount of lithium, it changes from orthorhombic to monoclinic structure. So there is a structural change in lithium, so from orthorhombic to monoclinic. And then when you are going to extract more lithium from it, it changes from monoclinic to hexagonal. So there is a big structural change in lithium cobalt oxide. And finally, when the lithium is completely extracted from it, it changes to orthorhombic 1 structure. So during the charging and discharging, the structural change plays a very vital role. So in order to avoid the structural change, the engineers who developed the battery first decided to restrict the operating potential. That is, they decided to extract only 0.5% of lithium. So in this region, lithium cobalt oxide exists only from lithium 1 to lithium 0.5. It exists only in orthorhombic phase. So therefore there is no structural change. So therefore the cathode material will be stable. So because of only 50% of lithium is extracted, the theoretical capacity maximum practical capacity which can be achieved is only 50% of lithium cobalt oxide. If we can extract 100% lithium from it, then we can achieve the complete capacity. In this case, due to the structural change, we cannot achieve up to this. And the next cathode material which has been used is lithium manganese oxide. Similar to lithium cobalt oxide, lithium manganese oxide also shows structural change, that is from phase 1 to phase 3. As you can see, it has 2 structures, 2 steps. That manganese oxide is changing from phase 1, phase 2 to phase 3 with the change in lithium content. So we need a stable material which does not change any phase during the insertion and deinsertion of lithium. Therefore, the performance can be achieved. However, even in the case of lithium manganese oxide, it is not possible. And the third class of material is lithium iron phosphate. This material, during charging and discharging, it shows a flat profile, which means that lithium iron phosphate does not change any, does not have any shape change during the insertion and deinsertion of lithium. Therefore, lithium iron phosphate has a higher theoretical, higher energy, higher density compared to all the cathode materials. So we could achieve the 95% of the theoretical capacity in case of lithium iron phosphate. So nowadays we are all trying to achieve the complete potential of lithium cobalt oxide and lithium manganese oxide by adding several dopants into it, and to increase the performance, and to decrease the structural change. And what happens what happens, as I said, mentioned, the structural change plays a very vital factor. So you are going to fabricate a device by stacking a cathode, an electrolyte, and an anode. So the electrolyte is an liquid. So to stop this, we are placing a separator, that is a porous membrane, and fabricating a cell. So during charging and discharging, your cell size is fixed. So you are wrapping it in a plastic container, and the cell size is fixed. So if your material is going to change your shape, so in the case of lithium iron phosphate, as you can see from lithium, removing 0.5% of lithium from lithium cobalt oxide, it has a volume change of 3 to 4%. And similarly, on the other side, graphite, when you are going to add lithium into carbon, there is a volume change of about 6 to 7%. So in case of lithium cobalt oxide, combining these two, it leads to a volume expansion of 10%. So this increasing volume gives a high pressure on the separator, which is a porous membrane, and this gives a stress in the cell, and this decreases the cell life in case of lithium cobalt oxide. But in the case of lithium iron phosphate, this material does not have any phase structural change. Does not have any structural change, and it shows a very good and it shows a negative volume expansion during lithium insertion and exertion. Therefore, combining this with lithium carbon, the volume change becomes zero. And this if you are going to make a battery based on this, it does not have any volume change, and the performance of the battery is more compared to lithium cobalt oxide. And to compare all the cathode materials which have been developed at present, lithium nickel, the present generation batteries which have been used is we are using in at present since 2016, most of the batteries are using lithium nickel cobalt manganese oxide. And still lithium, there is no other cathode material which shows a good zero volume expansion during or no structural change during charging and discharging, other than lithium iron phosphate. Even in case of the new developed materials, it shows high potential, very high capacity, but still it shows volume change. So the operating potential has to be controlled based on this. So we have to find a new material which shows no structural change during charging and discharging. And the other issue, as I said, the explosion of the batteries is because of the organic electrolyte which is being used in this. So to avoid this, as we all know, organic electrolytes are highly inflammable. In this case, we are using ethylene carbonate and propylene carbonate as an electrolyte. So this has a very low flash point at around 80 degrees centigrade. These electrolytes will get into flames. So how this affects the performance of the battery? So most of the batteries which are being developed is designed to work in a temperature range of 0 degree to 40 degree, or around 40 to 50 degrees centigrade. But we need during continuous operation or during accidents, the battery temperature it increases. And so how the explosion takes place? So this one shows the stage 1, the onset of the overheating. That is when your battery is charging and discharging for n number of times, there are several side reactions which are taking place on the graphite, on the anode, or else on the cathode. So these side reactions could not be avoided. We are all trying to this, and because of these side reactions, there is a formation of lithium dendrite, which lithium metal is being deposited over the surface of the cathode. And during longer usage, the lithium dendrite, it grows longer and longer, and it pierces into the separator, and it contacts into the cathode material. Therefore, there is a short circuit between the cathode and the anode, and this short circuit leads to a weak current. So when there is a big current, the cathode is getting decomposed. So decomposition of cathode means lithium cobalt manganese oxide or lithium cobalt oxide. They are all oxide based compounds. So when the cathode material is going to decompose, oxygen gas is removed, released from it. So this oxygen, as we all know, is highly flammable, and when it reacts with the organic liquid electrolyte present in it, the temperature heat generated on the oxygen and the organic liquid, it starts to burn or it starts to explode. This is what the reason the liquid electrolyte is not stable, is not safe and in the present generation lithium ion batteries. So how to overcome this? Either instead we should change the liquid electrolyte from organic electrolytes to ionic liquids, or we can change this by using all solid state solid electrolytes. So just if you remove the liquid and place a solid into it, so that you can avoid the problem of liquid electrolyte. And so in our group, we are all working to develop all solid state batteries. So in this case, we remove this liquid electrolyte and we add a solid electrolyte in this in place of the liquid electrolyte. We use a glass material as a solid electrolyte, and we sandwich in this structure by using PLD technique, pulse laser deposition technique. We develop thin film batteries. And there are to have a all solid state battery, you need a solid electrolyte which has a conductivity or a performance similar to the liquid electrolyte. There have been several new solid electrolytes have been invented or developed starting from 1995. The first material to be solid electrolyte to reach the conductivity of 10 power minus 4 is Garner type lithium lanthanum zirconium oxide. And then there are several sulfide based materials, lithium sulfide and phosphate sulfide and lithium germanium phosphate. All these materials are nowadays are reported to have a conductivity of about 10 power minus 3 at room temperature. So these solid electrolytes can be used in the all solid state battery. And as I said, if you change the cathode material, you can increase the potential of your battery. So we used lithium cobalt manganese oxide based cathode materials, lithium cobalt manganese oxide. This can give you a discharge voltage of about 5 volt to achieve this. So we developed a 5 volt class lithium ion battery by using lithium cobalt manganese oxide and lithium metal. So we used a pulse laser deposition technique to develop this battery, and the battery showed a good performance. So, however, we could not achieve the complete performance in the 5 volt range. What we expected is to have a high capacity in the 5 volt range, but when we first developed the battery, the capacity in the 4 volt region, that is at around 3.8 voltage, is due to the manganese reaction, manganese reduction and oxidation reaction. But we need the reduction oxidation reaction of cobalt. But in the case it was not possible. However, so we changed the experimental condition. We increased the oxygen partial pressure from 20 Pascal to 100 Pascal during the deposition, and this led to here increase in the cobalt redox capacity, and we could achieve 50% of the cobalt capacity, but still the capacity in the 4 volt region manganese redox reaction could not be completely removed. So we are all now working towards to decrease the manganese capacity and increase to have the capacity only in the cobalt region. So this all solid state 5 volt class all solid state battery has been under development, and there are we are yet to publish these results. And instead of lithium battery systems, lithium metal, what are the other battery systems we can use? As you can see from this figure, if you are going to change from lithium ion, which shows 200 watt hour per kilogram, if you change the cathode from lithium cobalt oxide, and if you are going to use any oxide conducting materials, if you develop a lithium air battery, you have a very high energy density. And if you change the cathode from oxide to sulfide, if you use sulfur as the cathode material, then you have high energy density. And if you use, instead of, now at present we are using carbon as the anode, so if you use lithium as the anode and develop a lithium sulfur battery, you have a high energy density and high power density battery. So I will skip this slide. So next, we try to develop all solid state battery using lithium sulfur battery, because lithium sulfur battery has a very high capacity and it has a high energy density compared with the lithium ion batteries. So in case of lithium sulfur battery, organic electrolyte is sandwiched between lithium and sulfur. During charging and discharging, sulfur will change change to lithium sulfides, and then finally lithium sulfur, Li2S. And the one problem with this lithium sulfur battery is the formation of these intermediate compounds. So these intermediate compounds are soluble in the organic electrolyte, and finally there are some insoluble species. This starts to deposit on the cathode material. Therefore it decreases the active material, or the it decreases the performance by with longer cycle time. So if we can restrict these insoluble compounds, then we can have a very good battery which has a capacity of about 1200 milliampere hour per gram, and this material shows no shape change in this region. So we can have a very high energy density battery which can be developed. So for this case, we developed our collaborators, they developed a solid electrolyte based on borohydrate compounds, lithium closoborate, and they have developed a lithium sulfur battery by using this. And this battery is shown to have a specific capacity of about 1000 milliampere hour per gram, which is about 4 times higher than the present generation lithium ion batteries. Therefore by developing a all solid state lithium sulfur battery, we can have high energy density and high capacity batteries. So with this I will conclude my presentation, and thank you so much for your kind attention.
I am Dr. Manimekalai from Department of Physics, St. Joseph Institute of Technology. I thank Dr. D. Arun Kumar for his sharing his knowledge with us. It's very highly informative and useful session. Thank you, sir. And there are several questions raised by our participants. Just I will give the view of it. You can carry on with your answers, sir.
Okay. Unnikuti, can we use supercapacitor by replacing battery in electric vehicles? Actually, supercapacitors, it has very high power density, but it does not have high energy density, as I showed in the Ragon plot. Supercapacitors have high power density, so we can use supercapacitors only to start the battery. So capacitors will you can extract energy from the capacitor as early at a faster rate, but to have a battery which has to last for a longer cycle time, you using supercapacitor only as a source is not recommendable. But combining a supercapacitor and a battery in a car will be a suitable way to use in electric vehicles. Okay, next question. Sivapriya Ravi, aren't electric cars dangerous in an accident? Actually, the picture which I showed about the explosions in battery, the Tesla car, which was a car which was burning in flames on the highway, is based on organic electrolyte used in it. However, nowadays several research groups have been trying to change the organic electrolyte. So by from using, instead of using organic electrolytes, if we use ionic liquids, which has the same performance, similar value performance of as the organic electrolytes, maybe these accidents can be rectified. There are many research groups around the other car companies. They are all working to avoid these accidents. So hopefully, in the near future, we will have a electric car with zero accidents due to the liquid electrolytes used, or to the other problems faced. In soon, in next 5 to 10 years, it will be zero cases, I think so. Can I charge electric car in the train? So if I understand this question correctly, if you are going to transport your car from one station to other station, I understand that if you are shifting from one place to another and you want to charge your car on your train, so in that case, I think it is possible. Nowadays, we can charge our mobile phones even in trains. So similarly, we can have a inverter. Only the power supply has to be installed in the trains. So then I think it's possible. What is the status of India in using lithium-ion batteries in automobiles? At present, to my knowledge, there are very few companies in India developing lithium-ion batteries. As I mentioned, Mahindra and Hyundai, they are launching electric vehicles. I think they are all based on lithium-ion batteries. But most of the electric two-wheelers, which has been which is being used, is mainly based on lead-acid batteries or nickel metal hydride batteries. And nowadays I'm hearing many of my friends that lithium ion batteries based on electric scooters is being also launched. At present, the contribution of lithium ion batteries of electric vehicles in India is less than 1%, combined with the total internal combustion engine. So in 1%, I think about 0.1% is only lithium-ion batteries. The rest is the primary source is lead-acid batteries in India, to my knowledge. How many kilometers can we travel when the battery is full? It depends upon the manufacturer. As I said, in case of Hyundai Konta, which is going to be launched, which is launched, I think they have reported a value of about 400 kilometers in a single charge. But if you are going to buy a Tesla Motors car, then the kilometers will be increased up to 600 kilometers. So it depends upon the number of batteries installed in your car. So if your battery in your car, if your battery pack is about 48 volts or 36 volt or 60 volt battery, then you can travel a longer distance. So when you're going to, it depends upon the battery pack that is installed on the car. Can a solar panel or solar powered voltaic can be used in vehicles instead of batteries? Actually, in case of solar cells, if you want to use, it is going to convert the solar energy into electrical energy, but it is the energy is only converting. So using solar panels, you can get electricity, but to run a car, so you are not going to have the sunshine throughout the whole day. So if you are going to drive your car on a sunny day, then it is possible. You can just directly connect your solar panel to your motor and you can run. But however, when it is a cloudy day, when there is no sunshine, then you can't use your car. So you can combine a solar cell to a battery you can store the generated electricity from the solar cell in a battery, and then you can use it for driving. So now, to my knowledge, BMW and Toyota are thinking of using a solar roof or a solar shield on the car top to generate electricity and to charge the batteries. I hope in near future it will be also to be launched. Can we measure and rectify the amount of minimum pollutants exhausted from the electric vehicles? Actually, the pollutants, electric vehicles, we used to say zero pollution, zero carbon. What I mentioned, the pollutants is the batteries which is being used. We are all using lithium transition metal oxides, transition metals, lithium, cobalt, nickel, manganese. These transition metals are highly harmful, and we when you are going to dispose your battery, so nowadays we are changing our battery, mobile phone battery or any batteries now and then. So you have to have a perfect recycle system. So if you are going to dismantle your battery, and if you recycle it in a clear in a better way, then the amount of pollutants from the electric vehicles will be very, very less. So we have to find a suitable recycling technology, then it is possible. I think nowadays many of the companies, they ask the end user to return the batteries to their own to their showrooms, and then they send it to the recycling stations to use it again. Can we use radioactive materials as source of energy in batteries? I don't understand this question. How, to my knowledge, how we can use radioactive materials? I'm sorry, I could not answer this question. Which type of battery is providing good performance? It depends upon the locations or the places where it is used. If you are thinking about a starter battery, that if you in your car, the starter battery, lead acid battery is the best even till date. No other batteries can replace the lead acid batteries. That's why it has been standing long. And when you are going to use in your car, lithium ion batteries is giving good performance, but the cost of the battery is really higher compared to the nickel metal hydride batteries, which has the same nearly same performance, but still lithium in the present status, lithium ion battery is showing good performance in case of longer life longevity, and in case of the shorter power where the power density which is highly needed, lead acid batteries are the best. Now more number of researchers are going on supercapacitors. Can we use it effectively? Yes, of course, because as I said, supercapacitors can deliver high power density. So at places where we need, we have to extract the electricity in a shorter time. Supercapacitors can be used. So by combining, nowadays people are all thinking to store energy by using using supercapacitors and batteries in parallel. So nowadays we are just generating electricity from coal stations, from thermal power plant, or from a nuclear power plant, or from wind energy, or from water energy. But to store these energies, we don't have any way. So if we can store this energy by using batteries and by using supercapacitors, then if you are going to use a supercapacitor and a battery combined in your home during a power shutdown, if you are using an inverter, your home appliances, every appliance will start to use the extract the current from the battery. So if you are going to use a supercapacitor over there, at first when the high load of power is going to be extracted, then supercapacitor will be the best. And after that, you can shift it from supercapacitor to a battery, so that the energy can be slowly utilized from it. Supercapacitors are also having a part in the energy storage devices. How can the battery should be disposed properly, as throwing in trash is common nowadays? Is there any recycling process available? Uh, Actually, as I said, the batteries has to be disposed properly. The AAA cells or AA cells which are using nowadays, you before throwing it, just cover it with a cellophane tape or any other insulation tape, and then you can throw it. But collect all the batteries one place. I don't know whether there are some recycle centers in India or in Chennai. But here in Japan, what they do is, before throwing your battery, they used to wrap the battery using insulation tape, so that the positive and negative terminals does not get short circuited. And then they used to collect all the batteries in a single place. And the government, they used to collect all some electronic stores. They have a special place to dispose all these things. From there they collect this and they send to the recycle centers, which is associated with the industry. But we should be very careful in case of disposing all these things. Hopefully in the near future, in India also, we'll have a good recycling system. Can you compare IC engine vehicle with battery fitted vehicle by performance and cost? It's the performance of a battery vehicle with a IC engine vehicle is about the energy density. If we mention it is about the energy density of a electric vehicle is only 400 watt hour kilogram. But in case of IC engine, it is 4,000. So it is 10 times. The IC engine delivers 10 times higher performance when compared with the electric vehicles. And the cost, as you at the present state, in the present day in India, I remember, to my knowledge, it is about nearly 1.5 times higher than the IC engine vehicle. So if you are going to buy the Hyundai Conta, on the website price, it is about 24 lakhs, and you can buy a very good IC engine vehicle in about 10 to 12 lakhs. So it is about 1.5 to 2 times higher than the price. But as nowadays, many companies are being entering into this electric vehicle market, the price of the electric vehicles will go down. Maybe in 2030, it has been reported that the price of the electric vehicles will be half the price of now. To the governments, as I said, everybody is trying to decrease the pollution ratio. So government are giving subsidies if you're going to buy a green energy vehicle, either it is hybrid vehicle, or else a fuel cell vehicle, or else a battery vehicle. Indian government is offering maybe around, they are giving tax discount. I think the GST is from 12%. They have decreased from 12% to 5% if you are going to buy a green vehicle. But still, the price is higher and the energy density from the IC engine is higher. So that's why people are very much hesitant to move from IC to battery vehicles. But we have to change. Otherwise, we are going to be in trouble. So we need support from the government in this case.
Thank you once again, sir, for your patience and your answers for our participants. Thank you, and it's a very wonderful session, sir. Thank you for your inspiring and innovative presentations, also, sir. Thank you so much.
Thank you so much.
So gratitude is not the greatest virtues, but parent of all others. Yeah, I am here to present vote of thanks. First, I like to thank our chairman, Dr. B. Babu Manoharan, St. Joseph Group of Institutions, Mrs. Jessie Priya, Managing Director, St. Joseph Group of Institutions, and Mr. Sashi Shekhar, Director, St. Joseph Group of Institutions, for giving us an opportunity to conduct this international webinar. I also extend my gratitude to our principal, Dr. P. Ravichandran, St. Joseph Institute of Technology for its constant support in conducting this event. Finally, I thank our department head, Dr. N. Batmamalini, and convener of this webinar, and all faculty members for giving their full support to this event to a great success. Once again, I thank all the participants for their participation and kind cooperation. Thank you all. Thank you very much.
Thank you so much.
Participants, the feedback form is posted in the chat box. You just fill it, then only you will be getting the e-certificate generated. So mandatory fields has to be filled compulsorily. So participants kindly filled all the required fields, then only it will be useful for you to useful for us to generate the e-certificate. Thank you all.